Now, that we get the third problem of tutorial 3. Again it is a EEG signal we get, okay, and we get 10 simultaneous recording of the EEG, and here we get spike and wave complexes. We will see that how the spike and wave complex looks like. Again sampling frequency is same as the previous one, 100 hertz, and the spike and wave, one spike and wave complex is taken as a template, and we have to use cross correlation or we need to use a match filter. So, in this case we will take a match filter, because already we have seen how to use the cross correlation in the previous problem, and we apply the procedure in all the channels and study the result to detect the spike and wave complexes. Okay. So, let us see how we have to proceed for that. The first ritual is to get the data and then the corresponding MATLAB file, which will tell us the format of the data and help us to read that data. Then we have to keep the signal and the MATLAB file that in the same directory, that is the working directory of our the MATLAB. Now, the first thing that to view the signal. So, for that we have chosen the EEG to the F3 channel. You have loaded that EEG F3 signal, sampling frequency is noted, the length of the signal that is taken, and that we have that length, according to that we are calculating the value, and we are taking that signal, we are dividing it with the maximum value to normalize it, okay, and we are normalizing it and keeping it in the EEG 1. Okay. We are keeping the all of them, all the 10 channels into this variable at different rows. The first row is fed with the channel F3, and then we take the plot of that F3. So, axis type to makes it that to just keep only that area used by the graph. Okay. Now, let us see the how the plot looks like. Okay. And axis of make sure that x and y axis are not drawn, and here we get this is the spike, this portion is the wave. Okay. So, if we take that from here to here, we can get that this is the interval is the spike and wave. The spike and wave are repeated number of times in this signal. So, next thing is that we have to plot all of them. So, for that we can use the same command so many times with subplot, and at the end we would like to put actually a marker to show that 1 second mark. Okay. So, for that 2 that what we do, initially we put it 0, the first value is put as 1, and then when actually the count is matching with the our sampling frequency, that is 100 that the remainder is 0 in that case. That means, count is becoming 100 or multiple of that, then only remainder would be 0, then we make it 1. So, in other words, every second passes we will have 1 tick. So, here is the signal that is shown, that we have all the 10 channels, and here these ticks are showing that this is 0 second, this is 1 second, this is 2 second. Okay. So, that is the way all the channels are shown all together. Now, we need to find the template. Again, the choice of template, it is done manually. That what it is done, that for the first channel of the EEG, that is, we have taken the F3 there. So, there we are taking the part sample 60 to 82. That means, we have 23 samples are there in that template. So, this part we crop it and store it as the value template. Now, once we have to create the match filter, the first thing what we have to do, we need to flip this template, and exactly that is done by this command wrev, which reverses the template. So, if the template is something like this, okay, or let us draw something asymmetric, say if the template is like this, after the flipping it would look like this. Okay. So, we have done this reversal here, and this is the impulse response of the match filter, and we have actually initialized the use that to keep the we keep that in the variable nu. The name is chosen just to keep in mind that this is the numerator of the filter, because we will use the filter command and we will define some denominator polynomial, that is nothing but 1, because it is an FIR filter, and with that numerator and the denominator polynomials we create the filter handler HD1, okay, using the command dfield dot df2, again direct form true we are using. Now, this is the, let us look at the plot of the template and that match filter. That here at the top we are showing the template, first the spike here, and this is the part wave. So, after that flipping, the match filter impulse response, that smooth wave will come first, followed by the impulse, okay, or the spike. So, this is the transfer function we get, and let us proceed. Let us see how to get the match filter output. For that, we are using the filter command with HD1 is our filter, and we are taking one channel at a time. First we are starting with the channel 1, that is F3, then we carry the same operation for the other channels, and the output is given in the variable C1, and for the plot we have to issue that figure command. For the brevity of the space we have dropped that. So, if we do not give that command, it will rewrite on the previous plot, okay. And we divide the plot into two parts, subplot 1 and plot the EEG signal first. We write the title and the labels, and then that what is the match filter output is given in the lower half, okay, and we give the appropriate label for that. So, here we see the output, that this is the signal with spike and wave in F3, and as we have taken one part from here as a match filter, we get the peaks here. So, all of them, they are indicative of the presence of that spike and wave. Okay. So, so many peaks, each one of them, they are signifying that spike and wave is present in this channel. Okay. So, now we do the same operation in the remaining 9 EEG channels. Okay. So, let us go ahead with that. Here we are showing it for F4 and C3. Next, we get it for channel C4 and P3. Then for P4 and O1. So, for all these cases, we are able to get the that we have the peaks present, high peaks, which signifies that our that spike and wave signal is present in all these channels. Now, we go for Q2 O2 and T3. Again we have the same finding. Then the last one, that is T4, again we see the high peaks in the match filter output, signifying that spike and wave is present. So, now here we summarize it, the peaks in the filter operation, that signifies that we have the spike and wave complexes. However, another thing we should look at, if we go for any of the signal, there is a lag, that wherever the spike and wave is there, if we look at the spikes, we will see that it is lagging the, here is the complex, that the peak is occurring little later. Okay. That is because the lag introduced by the filter, okay, that our template has a finite length, and when we try to use it as a causal signal, that we have to add some delay, and that is the lag is responsible for this lag. Okay. So, if we have to find out the location of that, then we need to be careful, we need to take care of this lag. However, that was not the task here. So, we leave it here and we say that the third problem of the tutorial 3 is completed. Thank you.